Now we turn to another language for another example of separating structure from behavior, that which we previously solved with the visitor design pattern. So in this example we use Lisp. Lisp, for those of you who don't know it, is a language allowing us to write code using not only object-oriented paradigms, but also functional style. Syntactically, we delimit all expressions with parentheses, and we also use prefix notation, meaning that immediately after a left parenthesis, we use keywords or operators, and after those keywords or operators, we provide arguments. In this case, we define a class called expression with inheritance list and optionally some values. Fields in Lisp, slots in fields in Java, slots in Lisp. So this is a definition of a class expression, which is a class without any base classes. So in Lisp there may be several base classes. Here we have none, and we have no class-specific fields or slots. As a subclass to our expression, we have a compound expression and an atomic expression. So this is rather similar to our previous example with abstract expressions in Java. Compound expressions are not further subclassed into additions and subtractions. We simply say that we have a left, an operator, and a right part of our compound expression. And these other parts describe that we can provide left and right operator arguments to the construction of a compound expression. We can also have methods for obtaining the left operator and right part of a compound expression. So these are access methods we describe. Atomic expressions simply have a value slot, and this is all there is to a definition of classes. So classes in Lisp are not descriptions of both data and associated behavior, but only data and inheritance relationships. Then, when we define behavior, we do it separately from classes. And the reason is that at runtime we choose an appropriate recipient of a method invocation, not only based on the leftmost argument, or the argument which is syntactically different from others in Java by being written to the left of the method. But here instead, we say that the method is at the center, and then it receives a number of arguments, and it's defined separately from classes. So in this case, we define something called a generic method, meaning that it can have several specific implementations depending on the types of parameters. So we say that the generic method is called getValue, and it has two specific implementations. One where we obtain a compound expression as an argument, one where we obtain an atomic expression as an argument. And here we call that argument self. This piece of code means that we should invoke the operator on the compound expression on that which we receive when we apply the getValue method on the left part and the getValue method on the right part of the compound expression. So when we construct a compound expression, we supply an operator, and that operator can be used as a function type object. That is, we don't have to hard code a plus or a minus anywhere. We can simply supply it as an argument to func call, which invokes whatever operator the compound expression has. So this is one definition of getValue. This is another. And we recursively call getValue in the definition of getValue here. So getValue of a compound expression means get the value of the left part and get the value of the right part. Depending on the types of the right and left parts, either this definition or this definition will be used. These are two examples of expressions. The first expression is simply 3 times 4. And the second expression is a compound expression which has as its left operand 3 times 4 added with 5. So if we were to call the getValue method, we would hope to get 12 here. We'd hope to get 17 there. Let's see. At the bottom, we obtain the result 17 from the expression getValue applied on expression 2. So interactively in Lisp, we can change to some other code. So Lisp is an interactive language, or rather can be run interactively as well as compile form. So if we get the value of expression, we obtain 12. Now, in order to separate behavior, in Java we had to write a visitor. Here we simply write new method definitions apart from the original structure. Note that here we don't have to make this double callback and implement except methods on expressions and compound expressions and atomic expressions, and then use those except methods to call a visitor back. Here we simply define methods outside our classes. So we add new behavior by adding a new method.